Hello Geometry, I'm coming at you with a new video. It's 6.3. It's a little late coming out, but hopefully this will be helpful if you haven't quite tackled that section yet. There are 3 videos that I posted in Google Classroom. You need to stop this video right now and watch those if you haven't already. So, pause, watch them. Okay, now that you've watched those videos, these notes will make a lot more sense. So, number 1 is the first official notes example that I'll be checking. We're developing some proof by basically saying, how can we determine which of these are congruent using the angle-side-angle postulate? So remember, it has to be the side included between 2 corresponding sets of angles that might be congruent. So when we say, name 2 triangles that we know are congruent from ASA, we got to think, okay, this has angle-side-angle structure. So we know that this one's in the mix right now as one of our 2 triangles. This one has angle-side structure. So right away, that one's not going to be congruent to either of these based on the information given to us if it's just ASA. Now, in this final triangle, you see angle, side, angle, so that puts it into question, that answers our question. This triangle is congruent to that triangle because angle is congruent to angle, so triangle P is congruent to triangle V. This is how we're going to start it out with because I'm just starting out with the one little dome right there. Now we move on to the side that's included, so you're going from P to R, which means you're going from V to W. See, the R and the W, they correspond. So P to V, R to W, and then W to X. X and Q. So PRQ is congruent to VWX because of angle, side, angle. I'm a little bit rusty right now, so there we go. Check out number 2. See if you can pause it and figure it out on your own. All right, it's got to be angle, side, angle. So when you see angle, side, angle here, we know that this is probably the one we're going to be using. This one's kind of tricky because it's got side, angle, so it could be a few different things. But look at the last one. Angle, side, nothing else. And if you go backwards, there's a side. So side, angle, side would work with this one. However, it specifies it's got to be ASA. So triangle ABC needs to be congruent to this one right here. So these are the 2 in question that are congruent. Single dome A goes with single dome E. Moving to B, it's the absent no dome, which is D. So AB would be ED. And then double dome C would be double dome F. So triangle ABC is congruent to triangle EDF. All right, let's check out 5 through 7. So this is the same idea, except it's saying, tell whether ASA can be used to prove the triangle's congruent. No, pretty much the same idea, except maybe we don't have congruence at all. So when you look at number 5, you've got an angle of the top triangle is congruent to angle of the bottom triangle. You've got the angle of the top triangle congruent to a different angle of the bottom. Now, this is a shared side right here, so you can say that this side is congruent to itself. So, can ASA be used to prove the triangles are congruent? Yes, because the shared side is congruent to itself. All right, that's our answer for number 5. All right, number 6. You know what? I'm going to skip 6 and come back to it at the end because I think it's the trickiest one we have. All right, look at number 7. 30-degree angle here is congruent to 30 degrees there. All right. The 3 meters is denoting this side right here. So I could say that this side is congruent to this side since they're both 3 meters long. And then we have something interesting. We've got this angle must be congruent to this angle because it's a pair of vertical angles. Vertical angles are congruent angles, which are formed when you intersect 2 lines with one another. So we've got an angle, side, angle. Angle, side, angle. Yeah. Now, number 6 is a little bit trickier. Here's why. These little arrowheads are not congruence indicators. They're parallel line indicators. So what I'm going to do is I'm going to extend this out a little bit. And the reason being is because when we had parallel lines in the previous chapter, you guys had a whole bunch of different congruence statements from that. So what I'm thinking about here is, if we extended these lines and extended this one right here, we've got right off the bat, so try to ignore these for a moment. You've got alternate interior angles right there because alternate interior angles are congruent if you've got parallel lines. And the side itself is congruent to itself. So we've got angle, side, and if we can prove that these 2 angles are congruent to one another, we've got it. However, we don't got it, and here's why. Since there's no indication that these 2 sides are actually parallel to one another, there's no indication, we cannot say that this little sliver here is congruent to that little sliver there. We basically just have to say, we don't know. So, here's what's happening. For sure, this has to be congruent to this. For sure, this has to be congruent to itself. But beyond that, we do not know. And that's why we cannot prove it to be possible to use ASA for congruence. It would be possible if we had these little arrowheads here. If these little arrowheads were here, then you'd say yes. But those little arrowheads weren't given to us. All right. Next one we're going to talk about, and it's the last section of problems, 9 through 12. So we're basically saying ASA or AAS, what does this say? Can be applied directly to prove the angles. Okay, so it's kind of the same question. Can we use ASA or AAS to prove that the 2 triangles given are congruent? On our first one, we've got an angle right here, which must be congruent to the angle over here because it's a pair of vertical angles. So we've got side, angle, angle. So angle, angle, side, that works with angle, angle, side. Yes. Remember, the angles have to be consecutive in order to be considered angle, angle, side. Check out our next one. Oh, I just explained it. So if you guys were snoozing through the end of the explanation for number 6, just go back up to number 6, rewind the video a little bit. This side is congruent to itself. Because of alternate interior angles between these two parallel lines, this angle and this angle must be congruent. Then if you were to rotate this and think through this side's parallel to this side, you can state that these are alternate interior angles to those parallel lines. Because of that, we've got an angle, side, angle. Those two are congruent. All right, this last one, well, it sure does look like we've got congruence here. This side is congruent to itself. But something's kind of wonky here. Angle, side, but the angle here is not the angle there. It's all the way up in the corner. It's kind of like this triangle over here has angle, angle, side structure. This triangle right here has angle, side, angle structure. Here's what happens if I redraw them each individually on their own. So let's say that this is triangle A, and I draw it down here. And this is triangle B. And I draw it over here. The side that is congruent is not shared between the congruent pairs. So this would have to be over here in order for angle side angle to be proven for both of them. So this is kind of a tricky example. They threw a curveball at you. These you can't prove them congruent because of the AAS situation there. Is not matching up with the ASA. It's not possible. We're mixing theorems together. Kind of tricky. All right, then our last one, number 12. They're stating, let angle E be congruent to angle I. Let side FE be congruent to side GI. Now, what I'm going to do is draw these two triangles first with that information in there. And I think anytime you guys get confused, you should be drawing pictures to help yourself visualize these situations. So I'm going to draw, here's one triangle, here's the other. Let's just say that this is angle E, and it is proven congruent to angle I. It's a given. FE, so I'm just going to make this F right here. This side is congruent to GI. I'm just using the information that they gave me originally right here. So check that, check that. Now this is an interesting question. What else must you know to prove that FDE is congruent to GHI by two different methods? So method one. Angle, angle, side. What information do we need in order to show that angle, angle, side would prove these two triangles are congruent? Well, if angle D is congruent to angle H, then you would have angle, angle, side congruent with angle, angle, side. So if angle D is proven congruent to angle H, then AAS proves the two are congruent. So then we checked that question off the list. We've answered that part of number 12. Now, what if we wanted to use angle, side, angle? Method 2. Well, the information we would need is to say that angle F is congruent to angle G. So if angle F is congruent to angle G, then you'd have angle side angle proving the two triangles congruent. You'd prove this statement is true. All right, so those are the notes that you guys missed in class if you're being currently quarantined or if you just weren't in class. So yeah, get those jotted down and make sure you turn them in with your homework to get full credit for those notes. And coming up next, 6.4, I'll be going through those notes as well.